Subnetting is the magic ingredient that flavors the CCNA exam. It's the skill you'll encounter over and over. Think of it like dividing a large pizza into perfectly sized slices so everyone gets a piece. Master it, and you'll tackle IP addressing questions quicker than a pizza guy finds your door on a Friday night. I'll show you a foolproof method that works every time. No need for memorization, just stick to the process. Subnetting boils down to a couple of nifty formulas. First up, take 2 raised to the number of subnet bits, and that's how many subnets you get. Then, 2 raised to the number of host bits, minus 2, delivers the number of usable hosts. We knock off those 2 because we've got to reserve spots for the network and broadcast addresses. Think of it like booking a hotel floor. 2 rooms are always for housekeeping. Let's imagine you have a 26 network starting from a 24. You've snagged 2 bits for subnets, so 2 squared gives you 4 subnets. For the hosts, you've got 6 bits left, so 2 to the 6th power is 64. But chop off those 2 reserved addresses, and you end up with 62 usable hosts per subnet. There you go, subnetting made simple. Let's dive into the subnetting process. First, you need to determine the block size by subtracting the interesting octet of the subnet mask from 256. For instance, with a subnet mask of 255.255.255.192, you'll subtract 192 from 256 and get a block size of 64. Next, list out the subnet addresses by counting up from 0 in increments of that block size. Now, don't forget that the network address is the first address in each block. Moving on to the broadcast address, it's just 1 less than the starting address of the next subnet. Lastly, the usable host addresses are those cozy little numbers nestled between the network and broadcast addresses. Keep this game plan in mind, and you'll be subnetting like you've been doing it since dial-up. Variable length subnet masking, or VLSM, is like being a thoughtful chef at a dinner party, making sure everyone gets exactly what they want to eat. You wouldn't hand out giant steaks to everyone when half the guests are vegetarians, right? So, let's dive into the nitty-gritty. We've got an address space of 192.168.1.0/24. Picture the main office as the person who goes back for seconds and thirds. They need room for 100 hosts, so we give them a 25, which provides 126 usable addresses. Branch A has a more modest appetite, requiring room for 50 hosts, so we hand them a 26, giving them 62 usable addresses. Then there's Branch B, the light eater, needing only 25 hosts, so a 27 with 30 usable addresses works just fine. And for those tiny point-to-point WAN links, think of them as that small plate of appetizers needing only 2 addresses, so a 30 or 31 is perfect. VLSM is your tool to avoid serving a feast when all someone needs is a small snack. You've got the IP address 172.6.45.14 with a /20 subnet mask. Let's untangle this. A /20 mask is the same as 255.255.24.0, which means the third octet is where the action happens. Picture block size like slices of a pizza. Here, you're looking at 256 minus 240, giving you a slice of 16. Start at 0 and count up in 16s. 0, 16, 32, 48. Since 45 is nestled between 32 and 48, your network address is 172.16.32.0. What about the broadcast address? That's the last address before we jump to the next slice, so it's 172.162.47.255. Now for the host range. Think of it like a hotel where the corner suites are reserved. Your available rooms, addresses, are from 172.1.32.1 to 172.62.47.254. Clear as day. Practicing this will make it second nature. Let's jump into some subnetting traps you really need to be aware of. First off, when calculating usable host addresses, always subtract 2. Why is that? Because the network and broadcast addresses are like those reserved parking spots at the office. No one else can use them. Now the /31 subnet mask might sound a bit weird, but it's legit for point-to-point links thanks to RFC 3021. With a /31, you get 2 addresses, and yes, both are usable. Think of it like a cozy 2-seat table at your favorite restaurant, just enough for a private dinner. Moving on to the /32 mask. Picture it as a solo gig. It's a host route for a single IP address. Imagine having a hotel room all to yourself, no need to share. Next up is VLSM, variable length subnet masking. It needs classless routing protocols like OSPF, EIGRP, or RIP-v2 to function. RIP-v1 doesn't cut it. It's like trying to play a Blu-ray in an ancient DVD player. It's just not going to work. Finally, the /30 subnet mask gives you two usable hosts and is perfect for WAN point-to-point links, much like those express lanes that take you directly from point A to B without any stops. Keep these points in mind, and you'll navigate subnetting like a pro. That's it, folks. Subnetting demystified. We dove into block sizes, usable hosts, VLSM, and even that head-scratcher of reverse engineering an IP. If you want to nail this on the exam, swing by Courseiva.com and practice until you can do it in your sleep. You're more than capable. Keep at it.